So today we are going to look at Docker. So Docker is a containerization platform that has revolutionized the way developers create, deploy, and run applications. It allows the creation of isolated environments called containers that contain everything an application needs to run, from the code to dependencies and configuration, and any of the things that you want that supports the running of the application. So these containers can be easily moved between development, testing, and production environments, ensuring consistency and reducing the risk of errors. And if you are giving your work to someone else, and you can if you are dockerizing it, you can expect it to work perfectly in their system as well. So for you to be able to use Dockers, you need to download Docker desktop application, and you can download it from this website. It's a Docker website, and once you search for Docker, and you're gonna see Docker desktop, and download it from here. And once you download it, what you will need to do is make a Docker file, which you are going to look at now. And we are going to work on one of the earlier projects that we have done, and we are going to Dockerize it. I'm on my VS Code, and I'm going to show you how to make a Dockerfile for the previous project that we have done, which was bird sentiment analysis. So if you have looked at the sentiment analysis code, and if you have understood this thing, I'm going to change this thing into more of a Python files. So here I have in the source folder, what I have done is I have changed this notebook into different Python files, which is what in a real world problem, whenever you're going to deploy something, it's going to look like this. So you're going to have essentially the configuration in one file, and the data loader, and I didn't even care to upload and import a lot of the things, so I just pasted it in. You just don't have to worry about this thing, because I wanted to give you a structural understanding of what it is going to look like and a feel for it. So this is our code. So this is a working code, but this is not going to work in the source folder. But what we are going to pretend is this is our project. So let's just say this is the bird sentiment analysis project. So of course, if I have copied all the things, and if I imported all the things correctly, this would work. So let's just pretend that this is going to be a final Python file for a project, and we are going to create a Docker file and containerize this thing. Okay, so the first thing that you need to make is a Docker file in it. You just have to a capital D Docker file and no extension. We have already downloaded Docker desktop, so that's what going to be the engine of all of the things that we are going to do right now here. If you know nothing about Docker, the way I want you to think about it is as a computer. So in a computer, there is going to be an operating system. You can make folders, and you can copy files into it, and you can also perform certain commands. But all of these things are going to be performed through this Docker files and the couple of commands that we are going to write inside of the Docker file. So from Docker Hub, as I specified earlier, you can download Dockers pre-installed with different versions of Python, and also of course the operating system. Let's just say Ubuntu with Python 3.8, and you can download it from Docker Hub. And what we will do is we'll take one of those Dockers, which will have also already the version of Python that we are using, and a favorite operating system that we want. Once we have done that, we will need to copy the entire code into one of the folders inside of the newly created computer, let's just say, and from there we need to run it. And also we'll be installing all of the dependencies and configuration files, anything that we require for our project to be working perfectly. Since we have made an isolated environment like Docker, and if we can successfully run it from inside of the Docker, and if you are giving it to someone else also, it's going to work the same way, because it is running inside of an isolated environment where all the dependencies and configurations are already existing, so that the usual conflicts are not arriving when it comes to changing the system or operating system or computer or whatever. This is all possible because we are running it inside an isolated environment. Okay, so there are a couple of commands that you need to know for running a command, and for copying, and different things like that. So let's start writing the commands in Docker. So we are going to get a base image for our Docker, and that base image is going to be Python 3.8 installed, and this is going to be Linux. So our operating system is going to be Linux, and we'll already have Python 3.8 installed in it. So this is the from command, and from you can say Python. This is the name of the Docker image where I have in Docker hub. So what it does is this would automatically, the from command would automatically look for if you have like Python 3.8 slim in your local. If it doesn't, and then it's going to go to Docker hub and directly download this thing. And the next thing that we need to do is copy all of the files that we have into a folder that we create. So let's just say I'm creating a folder called app, and inside of this thing, this Docker, I've already mentioned that Docker is like an isolated environment. So inside this environment there are like file systems. So we are going to make a different folder in it. So we are going to take the base environment as, base image as Python 3.8 slim, which is Linux with Python 3.8, and then we are going to the file system and creating a folder, and then we are copying all of the things that we have in your source folder into the application. So before going into that, we'll need to, now I'm in the Docker, I need to cd into src. So now it's perfect. So now I'm inside of this folder. So this is our base folder now. So now all of these things will be this is all of our application files. So all of these things will be copied into app folder inside of our Docker. So once you have that, you can set the work dir as the application file folder. So whenever we run any command, so this is going to be our default working directory once you set this thing. So now I have copied it into a folder, and I'm copying that into a separate folder, and I'm setting it as the working directory. And once you do that, you will have a couple of dependencies. One required thing you need to do is make a requirements.txt file. So you are going to specify all of the modules that you have used. So inside of the requirement files, what we want is torch equals to its version, and let's just say 1.2, numpy pi equals to 2.2, and pandas and sklearn, and all of the things has to be mentioned in here, so that our system would take this file and install the version of it. So here also you can, in the command line, if you're going to your virtual environment, what you can do is you can look at the version of your different things that you used. So for instance, if you want to know the torch version, I can do pip freeze and grep, can say torch. It's gonna say the version of my torch. So torch 1.13.1. okay. So all of the different things can be done in the same way, and your version has to be listed in here. Let's just say we are only using torch and numpy. Now we can use the run command to run the installations. So installations we require are the requirements that we have for the project. So we'll need to download all the libraries and install it in the directory so that we can run our application. So we'll need to do this. So usually how we do this is run pip install our requirements.txt. The next thing that we want to do is just run our command. Let's just say our engine has something like if double underscore name equals to main. We are doing something like some function, let's just say we have a function in here, train, class train. So train dot train or something like this. Let's just say this is going to run our data, and it's going to return a model, and we have already specified, let's just say we have specified the path into the root itself. So once you say in the Dockerfile md, and you need to use double quotes, Python, you're going to run our file. So let's just say here it's engine.py, so it's engine.py. So now this is going to run our Python file, and it's going to return the model. So let's just say you are in a testing environment. You can also expose you can expose a port. Let's just say 80, and if you're using a REST API or something here, let's just say in the engine you're using a REST API, and you are forwarding that into a port, and what you can do is expose that port, and you're gonna get be redirected to a URL once you run the Docker. And you can also upload your data and test your model as well. So if you have set up a REST API or anything similar. So the next step is to make a container out of it. So for making a container, we look at what are the commands that we're going to use. Okay. Now for building a Docker container, you need to be in the folder that you have your Dockerfile at. So I have moved to src, which is where my application and also my Dockerfile for that application is at. So I need to run the command docker build t, and let's just say the name is my application, my app, and I'm going to give a period which would let the Docker know that my Dockerfile is at this current folder. So this is going to create a Docker file. We are going to run this thing. Once you have a Dockerfile or any other Dockerfile, let's just say someone else has given you a Dockerfile, then you're going to do docker run. And if you want to run the Dockerfile and it has some application endpoint in it, let's just say speech application, speech app, and you're going to run this thing. If you do this thing, and Docker, it doesn't really matter what folder you are at. Once you have a Dockerfile at your system, then it's going to search and run it. Also, you can do one more thing, docker run and speech app. This is going to run the file, but this is also going to allow you to get inside the Docker container, so inside the file system of the Docker container. So you're going to be able to see all the files inside the let's just say a Linux operating system that we have, like the one we have taken in here. And also you can pull it directly from the Docker hub using docker pull, and you can specify your account name. Let's say you have a username like John, and slash the Docker your speech app. So this is going to pull it from your account, and the speech app Docker will be pulled into your local, and later you can use docker run either if you want to get into the file system. If you don't want to get into the file system, docker run just speech app. Okay, so that's it about Dockers. So you can sort of like play around with all the different commands that I've shown you, and all the functionalities like run from copy work directory, run expose and cmd, things like that, and play around with it. Make a good source file first of all, not like the dummy ones that I have created. So you can make even a simple Python file that would execute something in one of the files, but it has dependencies with other files as well. So that should be a good starters for understanding and Dockerizing different applications. And you can even upload it to Docker push it, upload it to your Docker hub as well. You can do docker you can do something like docker and push and your username John, this is the dummy username, and create a repository. Let's just say my speech app, and you're gonna say the name of your container, which is speech app, and this is going to push your already existing speech app Docker into a repository that's called my speech app in your user. You might need to do some authentication for your Docker Hub account, but I'm sure that you'll figure it out. Today we're going to look at how to make Amazon EC2 instances. So EC2 is really one of the oldest and most important services on AWS, and it is a service that allows us to make virtual servers on the cloud. Now the EC2 instances run on top of the host servers. So these host servers are managed by AWS itself, and the EC2 instance that we make on top of that are managed by us. This is infrastructure as a service, and we are free to select the operating system that we make and different configurations related to the hardware as well. And we can use it to deploy websites or different applications and maintain other things on this EC2 instances. So it's essentially like renting a computer, and you can decide what sort of requirements that you have in terms of its hardware and software requirements. And it also has different facilities and abilities like networking and securities and scalability, a lot of other features as well. We'll just jump into it and we'll start making one EC2 instance. So once you make an AWS account, you can make a free tier account for a credit card or debit card. You can use it to make a free tier account. And there are tons of services on AWS, and EC2 is one of those important services for anyone who is a machine learning and deep learning practitioner. So let's look at it. So what you gotta do now is you need to first of all select a region. Now I'm on US East region, so that's okay for me, and I'm going to do EC2, search EC2 and take EC2. So what we are going to do now is onto EC2, and once we are in here, we can start by clicking these launch instances. So you can launch an instance. I can give a name, my Linux server. I'm going to name it as my Linux server, and you have different options to select what OS do you want, and I'm going to go with the Linux default OS. And you can look at what sort of system do you want, and here instance type, you can go for T2 micro. This is the free tier eligible one. So if you don't have a key pair already set up, what you can do is click in here, create new key pair, and you can give it a name and you can download it. So make sure you have it before you actually create an EC2 instance, and everything else is going to be straightforward. So I already have a key pair, so I'm going to take that, select that, and the network settings, you can actually edit it if you want to, which means you can create you can select the VPC that you want, and everything will be set as default because AWS already gives you different VPCs and security groups and network routers and things like that, so you don't have to do anything. And the subnet masks and everything by default there are a lot of them, so usually 4 of them by default. So by default everything is already there. So once if you are not actually selecting anything in network settings, everything will be default and you shouldn't be facing any problem. But if you have made a security group or anything VPC or anything such specifically, then you can actually go ahead and select it. It's not a big issue. Now we can look at the configuration, and if you want to add multiple volumes, you can do that. And make sure that if you are only going to use the free tier, make sure that whatever the settings that you select are free tier really. So you don't have to care about these advanced settings. You just can go ahead and launch instance, and it's gonna launch instance. So it's as simple as that. So you can try to look at different settings and different procedures for making EC2 instance, but in general this is going to be this easy. And if you want, you can even try like different operating systems and volumes and things like that. So it's going to be very easy. And welcome. Today we are going to look at Git and GitHub, and we are going to discuss some of the topics related to open source management and contribution using GitHub. So what I have here is a sort of a graph for using Git and GitHub all together. If you have a repository, or if you have some projects done in your local machine and you want to show that to your world, the number one thing that you can do it is like put it on GitHub. And you just don't want to put it on GitHub. GitHub can be used in efficient ways, like for managing different versions and stuff like that. So that's what this video is going to be about. So for GitHub to be working with Git from your local, what you need to have is Git installed on your system. So if you have Mac, you don't have to install it, it's already installed. And if you have Windows, then you'll need to install Git. So also you'll need to set up your SSH key on GitHub, which I will provide you as an instruction. You can try doing that. Okay, so there are typically two types of workflows when it comes to development. And what you can do is you can start building your project in local, and at some point once you have done something, you can push it to GitHub, or once you have finished, you can directly upload that onto GitHub. Or otherwise, if you are doing it in taking a lot of time and you are doing a bunch of different stuff all together, then you can slowly build it, and parallelly you can start uploading or pushing your code into GitHub for well documentation, and people also can use and try to understand the history of the development of your project. So what you need to do once you have written a couple of let's just say you have written 2 Python files, and one is like train.py and the one test.py, and you want Git to track them. So for Git to be tracking them, your workflow would look like something like you have a directory. Inside that you have written 2 Python files which are really useful. Now you like Git to track them. So you would open up your terminal and go to the directory where your files are placed. Then you would say git init, and Git is going to initialize, and Git is really ready to track your changes. And the next thing that you want to do is git add command, which is nothing but Git is asking like what are the files that you want to track, the ones that you have changed. So if you want to track all of the files that you changed, then you can do like git add followed by a period. Otherwise you can specify git add the name of the file. And once you have done that, you need to commit. So a commit is nothing but you are making sure that the code that you have written is some sort of a milestone, and it's really going to be necessary for the further development of the problem, and you want that code to be preserved. And at that point you would git add it, and you would git commit m, and you can also type a commit message. So it's equivalent to you saying, okay, I need this code, and also I would like to give a message showing what I have done up until this point. At this point your code is ready to be pushed onto GitHub, but you don't have a repository on GitHub. So for that you'll need to start a repository on GitHub. So you're going to do like new repository here, and once you have done new repository, and you can give a name demo, and you don't want to do anything else, you just have to do this much. You have the option to make it private or public, And you also have the choice to make a readme file or not, and some git ignore and things like that. So you would say create repository, and once you create the repository, what's going to happen is this. So all you have to do is copy this thing and run this command, git remote add origin, followed by the SSH that we have copied. Now we have successfully made a connection between your local repository that you have started working on and a remote repository, a blank repository which doesn't have any code or any files in it. So now you have this kind of a connection between your remote and a local repository. So all of your commits will be pushed to your remote repository. So what you need to do is git push origin, and you have to run this command, git push origin, and the name of the branch that you have. Name of the branch is going to be main or master. And once you have done that, what is going to happen is all of this code from your local is going to be pushed to a branch in GitHub, so which is going to be the master branch on your repository on GitHub. So, and that's it, and the problem is solved. Now you have the connection, and now you can keep on changing your local repository and keep on adding files at this stage and keep on committing at this stage, and you can skip these two parts which you don't have to do anymore, and you can directly do git push. And once you push it, it's going to uploading all the commits into your remote repository. So you can do that starting from your local and extending it to your remote repository. So that's one method. The second method is going to be starting on remote. Let's just say you have a repository, or you have some files in a repository, or you have just made a repository. Let's just say you are making a repository called a demo, and it's going to have, let's just say if I check this one, add a readme file, and if I made this thing, what's going to happen is this repository will be made with a readme file in it. Take a repository with some code or some file in it. So if you don't have such a repository, or if you are starting out a new project, what you need to do is make a new repository and check the add readme file, and it's going to produce a readme file. So you are going to have a repository on GitHub with just a readme file in it without much of information. At this point, your repository is going to look like a normal repository on GitHub, which would be just say I'm taking a random repository. So you are going to be led to this kind of a page where you're going to have one readme file only here. Let's just say if you don't see any of those files in here and you're only seeing one readme file in it, that's what your repository is going to look like when you make a repository, blank repository with just a readme file. And what you need to do is you're only also going to have one branch, which is going to be the main branch. So what you'll need to do is click on this code and go to this local, and you have a couple of options here. So you can do HTTP or SSH, and you copy this SSH, and what you're going to do is you'll go to your command, your terminal, and you'll change your directory to the current working to the directory where you are thinking of developing your project, and you'll cd to that directory, and you will just write this command on your terminal, which is git clone and the SSH that you have copied from the repository. So this is going to clone that remote repository that you have created with just a readme file onto your local system. And once it is cloned, that it is going to have, if your repository is going to have like multiple files, it is going to clone all of the files in it. So one thing that I need to mention is branches, actually, before I go any further in this one. So let's just stop at this point. This is the second method, and we have already cloned it. So now I'll explain you what a branch is. So every time you do some work, you are essentially is going to be on a branch. So when you are initializing a blank repository, GitHub is going to initialize a branch, and you are going to be on a branch. The branch name is going to be either master or main. So you're going to be a branch in a branch, and when you clone this thing, you are cloning one of its branches. So let's just say if I'm showing you, this is the branch here, this is the main branch, and if I take one of those another branch, maybe a random branch, you're going to see different code in here. But don't worry about that. There are multiple branch systems that you can do on GitHub, but when you're making a new repository, you are only going to have this main branch in it, and you can copy this SSH and paste it in your terminal and do that git clone and SSH, and it is going to clone your branch, your current branch. In a blank repository that you made, it is going to be a main branch, and that main branch will be cloned, which in our case is only going to have a readme file. And once you have done that, you're going to have the exact same copies of the same repository on your local and also in your remote repository. And now your process is like you want to write code on your favorite IDE, and you will go to that folder and you'll open this folder on your favorite IDE, and you will do some coding, and now that code looks really good. Now you want to commit it, so you'll do git add, and whether it's different files or all of the files, and then you do git commit, the same thing as we had discussed in here. And the next thing that you want to do is establish a connection between your local and remote. So you are currently on a branch, which is the main branch, and you would call git push u origin and the remote master branch. So remote master branch is also going to be main or master, so you can call this thing, and it's going to create that connection between the main branch in the remote local and main branch, the main branch in the local and the main branch in the remote. And once you have done that, it's over. So again, you can repeat this process. You don't have to do this again. You only have to do git add, git commit, and git push. Okay, so I'm going to show you how to start a repository in local and then push that into a GitHub repository. So for that method, we had to start from our local, which is what exactly I'm going to do. I have created a folder, and I have also created a Python file called train.py. I'm on my VS Code, and this is the terminal attached to VS Code. You can also use your own terminal and go to the folder where you have your development, and then do the process that I'm going to do. So first of all, in the file, this is inside of the train.py file, and this is a terminal in the current folder. So I can do import pandas as pd and import numpy as np, and let's just say these are the 2 lines of code that I have written, and I want to commit these things. So before that, I would want to call, once I want my git to track these changes, I have to call git init, and once I call git init, git is going to say okay, I'll track it. And the next thing that I want to do is I want to commit these changes. So before committing, I need to add it, git add, and I want to add everything, which is just one file. If you had multiple files, it would add all of the files. Git add and a period, and then I can say git commit, and I can also give a commit message, which is imports. The reason why I've given imports is I have only imported 2 libraries, and I just wanted to show that what I have done. This typically has to be a summary of what you have done before you are committing it. So that is done. So the next thing that you want to do is create a remote repository and establish a connection between the remote repository and your local. This repository, I don't typically include anything in this repository because I don't want to make it complicated. So demo, I'll just say I'm going to make a repository called demo, and I'm going to, you can keep in private or public, doesn't really matter, as long as you have the SSH connection. Either way is going to be fine. So I'm not going to make a readme file in this procedure. This is procedure number 1, which I explained, and you can say create repository. And once you create repository, this is what you're going to say, see, and you can either select SSH or HTTP, and I will always go for SSH, and you can copy this thing. What you're going to do is git remote add origin and the SSH. So this has established a connection between your local repository and the remote repository that we have made. And now we want to push this. So before that, I will show you something. If you do git branch, and it's gonna say git branch, and it's gonna say it's the master branch. So which means when you're initializing git on any directory, git is defaultly and assign a branch for all of the things that you're going to write. So this is here is the master branch, which git has already initialized. So you are on your master branch by default. So now what you want to do is, your remote repository doesn't have anything. So what you would try to do is, you will take this master branch and the code you have on the master branch and the commits that you have on the master branch will be taken from your local to your remote and placed it as is. So for doing that thing, we need to say we are going to have a connection between master branch in local, and also we are going to create a master branch, a branch named master on the remote, and push your code, push your commits from master of your local to master of your remote. So for doing that, you need to do git push u origin master, and it's done. And once you go to your repository, and now you see your train.py file and 2 lines of code that you've written in here. So any other change that you want to make, let's just say import what else, torch. You can import torch, and I added this file. Now I only have to do git add and git commit. I can say add a torch, and I've committed it. Now I don't have to do anything else. I can now, since I have already established a connection between the master branch in local and the master branch in the remote repository, now I can say git push, and it's gonna push it. So now I go back on my repository and I reload it, and I want to see import torch as well. So this is the first method of development. So now I'm going to show you the second method of development. This time I'll create a repository with a readme file in it. So I'm going to say this demo, and this is going to have a demo file, readme file, just because I don't want to create a repository without a branch at all, without anything in it. So once you create a readme file, GitHub is going to initialize a branch, and it's going to name the branch as main, and it's also going to include a readme file in it, so that we'll have an empty repository in theory, but it's going to have just a readme file, which is not going to have any information, and also it's something that you can change later. So I'm going to do this thing. So the readme file is just going to have the name that you have given for the repository. So now you have the main branch, and you have only one branch. You'll go in here, code, and you can select the SSH and copy this thing. What I'm going to do is, I'm going to clone this repository into my desktop, and I'm going to say git clone and my SSH. I'd like to access, okay. And now you're cloning our repository. So once you clone the repository, it's going to be ready, and I'm going to open it from VS Code. So now you can see the repository that we are cloned, and it has the same name, and it's got just one file, which is the readme.md file. And you don't have to, so this method is going to be fairly simple compared to the first one. So what you can do is, you can also do like a train.py file in it, and what you can do is let's just say you are import numpy as np. This is what you're doing, and once you have done that, you can check the git status here. You have added train.py, but you have not committed it. And also you can check git branch, which branch is it in. So this is the main branch. Now you have cloned your repository that was developed on GitHub, which had a main branch, and you are taking that into your computer locally. So this has a main branch by default because you cloned it. And now what you can do is set an upstream git. Once you have done it, so you can do git add period git commit m and a message numpy. Now you need to push it. So before pushing it, you need to set for the first time pushing it, you always want to do git push u origin main. The reason why I have written main here because the branch name in the remote is main, so I'm pushing this main branch into that main branch. So this is going to push it, and you can check it in here. To do that, it's going to have the train.py, and you can see it in here numpy as np. And the next time if you want to do something like import something else, and you have this code and you want to add it, so well, clear it. So you want to git add and git commit and a message something. And you don't have to you only have to git push now because these two branches has a connection now, so you just have to do git push. Yeah, so if you want to make, so that's the two of the methods. So if you want to make a new branch on GitHub, what you want to do is git checkout b. Let's say I want to make a branch called dev. So now if I look at my branch, my dev branch is on and main branch is off. So from now on, whatever the things that I would do in here is going to be recorded on the development branch or dev branch. So let's say I'm doing something called import, I'd say define a function called function that takes x and returns x square. And since I'm in the dev branch and I'm adding that, git add and git commit function. And I have to now, since I'm on a different branch, and it also depends where you want to push this to. So since you are now on the development branch, you need to push this thing into the remote development branch, but the remote doesn't have a development branch yet. So you want to make a development branch in remote and push it to remote. So you would do the exact same thing, git remote. So you would do you want to push it, but you would do git push u origin dev, and this is going to push this code into your development branch. So now you look at here, you're going to see two branches. Now you can see your development branch as well. So at this point, when the main branch was at this stage of the development, we made a development branch. So this dev branch is going to contain the extra thing that we written, which was the function. So then I push that into the development branch. That's the reason why it doesn't this function which I have written in the last is not on the main branch. So now if you're on a development branch and the next time that you want to push something, write something and push that to the development branch, you don't have to do git push u origin and you can do just git push, and it's going to push to your development branch if you are on the development branch in your local. The same goes to the main branch as well.